Okay, so what we're going to do is we are going to review for your chapter 7.1 to 7.5 test. I'm going to go over the review sheet and how to do every single problem because what I did on the review sheet is I gave you 20 questions, just like the 20 questions that will be on your test that you have tomorrow on Tuesday. Okay, so the first three problems that you have say, is the ordered pair a solution to the system? So what you're going to do is you're going to take this ordered pair, which is right here, 18, 11, and we know that 18 represents x and 11 represents y, and we're going to plug it into each one and say, yes, it is a solution, or no, it's not. Now, in order for the entire answer to be yes, it has to be yes to both equations. In order for it to be no, it just has to be no to one of them, okay, not both. So I pay attention and I notice that I put the y first. So I'm going to do 5 times 11 minus 3x equals, minus 3 times 18 equals 1. And we're going to get 55 minus 54 equals 1. 1 equals 1. So we know that that one checks out. Now let's do the other one. Okay, so I'm going to do 4 times 11 plus 2 times 18 equals 80. 44 plus 36 equals 80, and 80 does equal 80. So we know that the answer to this one is yes. This is what you're going to want to box in right here. Yes. Okay, so we go to do the next one. We're going to do the exact same thing. Negative 3 times 0, because I'm just replacing the x with a 0 and a y with a 4. So plus 3 times 4 equals 12. So we know 0 plus 12 equals 12. 12 does equal 12, so I know that one works out. Let's do the next one. So we're going to do 4 times 0 plus 2 times 4 equals 20. So I know 8 does not equal 20. Now, since one of them is yes and one of them is no, the whole answer is no because it's not a solution to the system. The system would be both of them. Okay? Then your next problem, we have negative 4 plus 2 equals negative 2. Negative 2 equals negative 2. Checks out. Then we're going to do 2 times 4 plus 2 equals 10. 2 times 4 is 8. 8 plus 2, 10 does equal 10. So this checks out for both of them. So our answer is yes. So these are exactly how the first three problems on your test will look. So then the next problems, okay, these are the easiest problems on the test and the review sheet because they've done all the work for you. They've taken the equations, they've graphed each of the lines, and all we have to do is look at where the lines cross, and that is our solution because we know when we graph lines, wherever they intersect is our solution. So I look at my first problem here, and I notice they cross right here. So my solution, I'm going to write it as an ordered pair, is 3, negative 3. And I box that in. So there's really no work to do at all. You're just using your eyeballs. So then the next one I look and I have these two lines. And I notice that they intersect right here. So I write my answer as an ordered pair, which is 4, 3. Okay, there are two problems like that on your test. Then the next three problems say graph to solve the linear system. So in order to graph to solve, the equations must be in slope-intercept form. Slope-intercept form is y equals mx plus b. I cannot graph anything unless my equations are in that form. So I look at my first problem here. Y equals negative x plus 3 and y equals x plus 1. Well, both of those are in slope-intercept form, so part of the work's already done. Now, all I need to do is I need to go and I need to graph each of these equations because each of them are going to make a line, and wherever the lines cross is going to be my solution. So the first equation, I'm going to graph it in red. We know that our m is technically negative 1 over 1, and our b is 3. So I'm going to go up to positive 3 and then down 1 over 1. And I'm going to keep going down 1 over 1, down 1 over 1, because then that's going to give me a nice straight line. So now what we're going to do is we're going to just draw our line through the points, because you always want to make sure you do draw your line through the points, because if not, it looks like you just have a bunch of ordered pairs, and it's actually a line. So then the next equation that we have here is y equals 1x plus 1. So you're going to go, our m is technically 1 over 1, because there's a 1 right there, and our b is also positive 1. So we're going to go to positive 1 on our y-axis, and then I'm going to go up 1 over 1. Well, right there, I already see where they're going to intersect, so I really don't need to keep going with the line, because you just need to go until you find their point of intersection. So the point of intersection is right here, which is, I need to write my answer as an ordered pair, because it's not enough just to show me where the lines cross. I need to know that you know what the ordered pair is, which is 1, 2. Okay, so that's how we do that first problem right there. Now, the next problem that you have on your review sheet says x plus y equals 1 and 2x minus y equals 2. So the first step that we said that we need to do is to get these in slope-intercept form. And I noticed that these are not in slope-intercept form. So the first thing I'm going to do is I'm going to subtract x on both sides. I'm going to write the 1 in front of it. So it's going to be y equals negative 1x plus 1. And then on the next equation, I'm going to subtract 2x. And I'm going to get negative 1y. Do not forget about this negative 1 right here. Equals negative 2x plus 2. So I'm going to divide everything by negative 1. And I'm going to get y is equal to positive 2x minus 2. So the m in the first equation is negative 1 over 1. And my b is positive 1. So I'm going to graph. And I'm going to go to positive 1, and then I'm going to go down 1 over 1. And again, I'm going to keep doing the same thing. So I have a line that extends most of the way through the graph. Don't forget, draw your line through them. Then the second equation forms the next line. Our m is positive 2 over 1. And our b is negative 2. So I go to negative 2 first, then I go up 2 over 1. Well, again, we are just getting lucky here, and the first point that I place is where they're crossing. So I don't have to draw my line very big. I notice right here is their solution, and so the answer is 2, 0. Okay, so here is the answer, 2, 0. Make sure you write the x first and then the y. And then the third problem that you had that says solve using the graphing method says y minus 2x equals 0 and 6y plus 2x equals 0. So we want to get y by itself again, so I add 2x to both sides, and I get y is equal to 2x plus 0. Then on the other side, I'm going to subtract 2x. I'm sorry, not the other side, but the other line. 6y is equal to negative 2x plus 0. Now, some people prefer not to write the 0. I like to write it because it tells me that my b is going to be at 0. 0 is a place on the graph, so I like to include it. Then I divide everything by 6, and I'm going to get y is equal to negative 1/3 x plus 0. Now I can actually graph the lines. So I'm going to take my graph here, and my first point on the first line, well, let's say our m is 2 over 1 and our b is 0. So I place my point at 0, then I go up 2 over 1, up 2 over 1, and I can also go down 2 over 1, go the opposite direction. Then my next equation here, my first point is going to be at 0. Well, right there, we know they're going to cross. Now, I do need to put the other point because I can't just leave it there. So I'm going to go down 1 over 3. Okay? Draw my line through these. And the point that they cross at, I notice, is 0, 0. Now, I know most of you can look at that before you even graph and say, oh, because they both have the 0 right here, I know what the answer is going to be. And that is great, but I still need you to graph it. Okay, so our graph is 0, or our answer is 0, 0. So then the next 3 problems that you have say use substitution to solve the linear system. Well, substitution means I always have to get one variable alone. It does not matter which variable you get alone as long as you get an x or a y. A lot of people get confused and they say, oh, well, because it's slope-intercept form, I have to get y by itself. That's not necessarily true. You can get x or y, whichever one's the easiest. So I look at this first problem here. And I've got to ask myself, is there a variable already isolated? Well, lucky for me, they have already isolated the y in the second problem. So that is, that step is already done. So I can just take this 2x plus 7 and I can plug it in for y in the top equation. We always want to plug it into the opposite equation. I would never want to plug it into the same one because nothing's going to work out. So I'm going to take 4x plus 3, and then I'm going to do parentheses, 2x plus 7 equals 31. And what I'm going to do is I'm going to do distributive property because now I have like terms and I can solve for x. So I'm going to do 4x plus 6x plus 21 equals 31. And then 10x plus 21 equals 31. So I'm going to subtract 21 on both sides. 10x is equal to 10. Divide by 10 on both sides, and x is equal to 1. Now, I'm not done. That is part of my answer, but I'm not finished. So you can plug this x back in to anywhere you see an x. I typically like to do it to this equation, the one that already says y equals or x equals, depending on which variable, because it's a little bit easier to find. So we're going to do y is equal to 2 times 1 plus 7. Y is equal to 2 plus 7. Y is equal to 9. So we want to make sure whenever we have the variables x and y to write our answer as an ordered pair. So my answer is 1, 9. So that's how we would solve using substitution. Now on the next equation, I realize that, okay, my first step has to be get one variable all alone. But there's not a variable that's already isolated for me. In the first one, we already had y equals. This one, we can see a variable that's probably going to be the easiest to get all alone, which is this y right here. Why did I choose that one? Because it's the only variable that has a positive 1 in front of it. Technically, the one, we don't even see it. It's understood. So the only thing I have to do to get y by itself is add 12x to both sides. So I'm going to rewrite y. I'm going to change my color so it doesn't get confusing. Y is equal to 12x plus 15. So now I can take this because I know what y equals and I can plug it in for the y in the next equation. So I'm going to do 3x plus 2, and then in parentheses I'm going to substitute in 12x plus 15 equals 30. Now I'm going to erase some of the work from the first problem since we already know what our answer is. So now I'm going to do distributive property, combine like terms, and solve. 3x plus 24x plus 30 is equal to 30. Then I'm going to combine like terms. 27x plus 30 is equal to 30. Subtract 30 on both sides and get 27x is equal to 0. So I divide by 27, and x is equal to 0. Again, I'm not finished because I have to have an ordered pair, an x and a y. So I can take this x and I can plug it in for anywhere I see an x. So you can choose this equation, you can choose this equation, or this one. I typically like to do, like I said, the one where the variable is already isolated. So this third one is the one that I'm going to choose. So I'm going to do y is equal to 2 times 0 plus 15. So it's going to be y is equal to 15. Again, because I have an x and a y, I'm going to write my answer as an ordered pair. Now, if you were given the letters like a and b, you could just leave it a equals this, b equals this. It doesn't need to be in an ordered pair. Okay, so those are the first two. Now the last one that we have using the substitution, I'm going to go ahead and erase everything so we have plenty of room, is I need to get a variable by itself. And I have lots of options on this one. Actually, I'm going to look again. Look at the second equation. Is there even a y in that problem? No, there's not. If I were just to give you x plus 4 equals 16, would you be able to solve that? Yes. So that's exactly what I'm going to do. This is the easiest problem in substitution that I could give you. So I'm going to subtract 4 on both sides, and I'm going to say x is equal to 12. There's one of my answers right there. So now I just take this 12 and I plug it into the other equation. 12 minus y is equal to negative 5. I subtract 12 on both sides. Negative y is equal to negative 17. Don't forget there's a negative 1 there, so I'm going to divide by negative 1, and y is equal to 17. So again, because it's an x and y, I want to write my answer as an ordered pair, 12, 17. So that's how you would solve using the substitution method. Then we have the next three problems which say use elimination method. Well, the word elimination speaks for itself. It tells us exactly what we want to do. We want to eliminate one of the variables in order to solve. So I look at the first problem here, but I notice an issue. Whenever we eliminate, we need to, basically we're adding and subtracting like terms. But I noticed that in order to do that, my like terms have to be lined up, and this problem is not in the correct order. We need it to be x, y equals our number. So a number is a constant, okay? So I look and I say, okay, the x is in the right space, but the negative 4y and the negative 24, they need to be switched. But because they're on the wrong side of the equals, I must do the opposite in order to move them. So I'm going to add 24 to move it over here, and I'm going to add 4y to move it over here. Once I do that, I now have 3x plus 4y equals 24. And I look at the second problem, okay? The x and the negative 2 are out of place. Again, because they're on the wrong side of the equals, I have to do the opposite operation to move it. And I get negative 1x plus 2y is equal to 2. Now I need to eliminate. Okay, so I've got to decide, do I want my x's to eliminate or do I want my y's to eliminate? And the truth is, you can do either one. You do not have to do the x's always or the y's always. I'm going to choose to do the x's because one of them is already positive and one's already negative. So I know that in order for something to cancel out, I have to have the same number, but one must be positive, one must be negative. You could do the 2 and the 4, but I would just have to multiply by a negative number in order for it to cancel out. So it wouldn't be wrong if you did it. You have to take into account a positive or negative sign. So I look at this term right here, 3 and 1, technically negative 1, and I ask myself, what is a number that both 3 and 1 can go into? 3. Well, that means this 3 is perfect. It already is a 3. I need this to be a negative 3. Well, it's already negative 1, so what do I need to multiply by negative 1 to make it negative 3? Just 3. But when I multiply one thing in the equation by 3, I have to multiply everything in the equation by 3. So what I'm going to do is I'm just going to rewrite both of these. So I'm going to rewrite the top equation. I'm not changing anything. I'm just moving it over. And then in the next one, I have negative 3x plus 6y is equal to 6. Now I look and I realize that the x's can cancel out, so I just add my like terms. 10y is equal to 30, and I can solve for y. Divide by 10 on both sides, y is equal to 3. Once I know what y is equal to, I can go back and I can plug it in for anywhere that I see a y. So I could do it for this y, this y, this one, this one, this one, or this one. So I technically have 6 options here. Now I'm going to do this one right here just because it's already x is equal to, so it'll be easier for me to solve. So I'm going to do negative 2 plus 2 times 3 equals x. Oops. Negative 2 plus 6 is equal to x. 4 is equal to x. So we can do 4 comma 3. And that is our answer using the elimination method. Okay? So I'm going to leave that up for just a second, and we're going to look at the second problem here. The second problem, I looked, does everything line up? X, y equals a number. Yes. Is there anything that eliminates already? Yes. The x's, positive x, negative x. So that cancels out. So I'm just going to add like terms. 5y equals 5. Divide by 5, and y is equal to 1. So now I can take this and I can plug it back in for anywhere I see a y. I'm going to do it for this y right here because x is already positive, so it'll be easier. X plus 3 times 1 equals 2. X plus 3 equals 2. Subtract 3 on both sides, and x is equal to negative 1. So my answer is negative 1 comma 1. And last but not least, so I'm going to go ahead and erase everything here so we have some room. I look at this problem. Is all my terms lined up? X, y equals a number. Yes, it is. Does anything cancel out? No. I notice that the x's both technically have a 1 in front of them, so it's already the same number, but in order for it to cancel out, one's got to be positive, one's got to be negative. So I asked myself, what can I multiply by 1 to make it negative 1? Negative 1, okay? Anytime we want to keep the number value the same but change the sign, we always just multiply by negative 1, which means I must multiply everything by negative 1. So now I have negative 1x, I'm just rewriting the top equation right below this second, minus 3y equals negative 3. So once you redo that, this equation becomes invalid. We don't use it anymore. Now, I could use it to plug a variable back in, but it's not going to be added with anything. So the x's cancel out, and I combine like terms. 3y is equal to 0. Divide by 3, and y is equal to 0. So now I can plug this back in anywhere I want to. So I'm going to plug it into the second equation. X plus 6 times 0 is equal to 3. I know 6 times 0 is 0, so x is equal to 3. So my ordered pair is 3, 0. So this is how we solve using the elimination method. And last but not least, well, not last, but the last section of our methods here says we can use any method you want. So you guys get to choose whichever method. If you like graphing, you can graph. If you like substitution, you can substitute. If you like elimination, you can eliminate. I'm going to look and I'm going to ask myself maybe which one would be the easiest. On the first one, I noticed that all my terms are already lined up. Probably not going to be easier for me to graph. Substitution, I don't already have one variable. I think elimination is probably my best way to go here because I noticed that the x's are already the same number. They each are 1. So what would I need to do to the first equation to get it to cancel out? Just multiply everything by negative 1. So I'm going to do negative 1x plus 1y is equal to positive 5. So this equation here, I don't need it anymore. The x's cancel out and I get 3y is equal to 9. Divide by 3, and y is equal to 3. So now I can take this and I can plug this back in. So I'm going to do it to this second equation right here. And I'm going to get x plus 2 times 3 equals 4. X plus 6 is equal to 4. Subtract 6 on both sides, and x is equal to negative 2. So then my answer is negative 2 comma 3. So I use the elimination method on that one. Now this next problem, I noticed that it's almost in slope-intercept form. So I could graph, or because it's almost one variable by itself, I can use substitution. You could also do elimination if you wanted to. I'm going to choose to do substitution on this one. Now, when I'm choosing methods, if on the first one you decided to do substitution or you decided to do graphing, you will still come out with the exact same answer. All right? It doesn't mean your answer is going to be different. That's the whole point of the three methods, is you can do any way and you should always get the exact same answer. So because it's substitution, I'm just going to sit here and I'm going to divide everything by negative 1 to get that y all alone. And I get y is equal to 3x minus 9. Now I'm going to take this 3x minus 9 and I'm going to plug it in for this y right here. So I'm going to do 3 times 3x minus 9 equals negative 5x plus 15. Distributive property, 9x minus 9 equals negative 5x plus 15. Combine like terms, so I'm going to add 5x. And I'm also going to add the 9 to move it over here. I just combined in one step. 14x is equal to 24. Okay, before I go any farther, I actually found an error. And this was probably a good thing that I did this, because when I multiplied, I only distributed the 3 to the first term. I must distribute it to the second term also, which is going to change things. So instead of this minus 9 right here, it's going to be minus 27. So then when I want to move this, I'm going to add 27 to both sides. And I'm going to get 14x is equal to 42. That's going to help me out. I'm not going to have any fractions now. So I'm going to divide by 14 on both sides, and I get x is equal to 3. Now I can take this and I can plug it back in and solve for y. So I'm going to do y equals 3 times 3 minus 9. Y equals 9 minus 9. Y is equal to 0. So then my answer is 3, 0. Okay, and last but not least, I look at this. They've given me a gift, basically, because I look at the first equation, 3x equals 12. If I were to solve, or if I were to give you that problem, could you just sit here and solve for x? Absolutely. So that's what we're going to do. Let's make it easy on ourselves. X is equal to 4. Now all I need to do is plug that back in to solve for y. 2 times 4 plus 6y is equal to 20. 8 plus 6y is equal to 20. Subtract 8. 6y is equal to 12. Divide by 6. And y is equal to 2. I'm running out of room, so I'm going to erase some of this. Oops. And my final answer is 4, 2. Okay, so this is using any method. And again, if you chose to do graphing or substitution or elimination differently on the ones that I did, then you should still get the same answer. So the last 3 problems that you're going to have on your test say, tell what type of lines the equations will be and how many solutions they will have. Well, in order to be able to do that, I have to put each equation in slope-intercept form, because I'm going to be able to look at it and tell you what type of line it is. So the first equation here, I notice I need to get y by itself. So I subtract 2x, and I get y is equal to negative 2x plus 5. And then in the next equation, I'm going to add 6x, and I get negative 3y is equal to 6x minus 15. Divide everything by negative 3. And I'm going to get y is equal to negative 2x plus 5. Now I look and I notice, okay, everything is the exact same in these. So whenever that happens, I know that they are going to be the same lines with infinite solutions. You must write both of these words because you're telling me what type of line it is, they're the same, and how many solutions it will have, infinite. If you only give me one, you're not going to get full credit on the test. Okay, so let's do the next one. We got to put it in slope-intercept form. So I'm going to add 6x to both sides. And now I get 2y is equal to 6x plus 4. Divide everything by 2. And I get y is equal to 3x plus 2. So the next equation, I'm going to add 9x. And I get 3y is equal to 9x plus 12. Divide by 3 everywhere. And get y is equal to 3x plus 4. So I look at these and I say, okay, just the slope is the same. Whenever I have the same slope, I know that the lines are parallel. Do parallel lines ever cross? No. So that means they have to have no solutions, or you can write parallel with none. And then last but not least, again, I want to get the y by itself. So I subtract 2x on both sides. And I get y is equal to negative 2x plus 7. Then I subtract 3x. And I get negative 1y is equal to negative 3x minus 2. Divide everything by negative 1. And get y is equal to positive 3x plus 2. Now I notice here that nothing is the same. When nothing is the same, that means each of these lines are doing its own thing, and it's going to be intersecting. And here's the problem that I saw, especially on the quiz, is people said, oh, because nothing's the same, then intersecting lines have no solutions. But that's not true. Intersecting lines have one solution. They will intersect or cross at one place. So these are the 20 questions that will be just like the 20 questions on your test that you will have tomorrow. This is the last test grade that will go in before your midterm grade. So this will determine whether some of you can exempt or not. So make sure that you study and that you are prepared for the test tomorrow.